The Death of Stars by Bryan R. A star creates light by fusing hydrogen into helium. When a star runs out of hydrogen that it can convert into helium, it takes several different paths. If the star is half the mass of our Sun, the electron degeneracy pressure is when electrons are packed together while the star condenses into a white dwarf. Some are forced into high energy states. After its active stage, when the star has no more hydrogen to convert into helium, the star condenses into a white dwarf. There is not enough space for all of the electrons to have low energy states. The electrons that are in a high energy state make a significant contribution to the pressure. Because of this, as the star cools, the pressure stays the same. The pressure keeps the white dwarf from collapsing under its own weight and exploding into a million pieces. A star can become a white dwarf in two different ways. One way is that the electron degeneracy pressure keeps the star from collapsing, and the star becomes a white dwarf because it has no more hydrogen to convert. More commonly, the star still has a little bit of hydrogen that it hasn't fused around the core. It creates helium, and the star expands into a red giant. A red giant is a star that fuses helium into carbon and oxygen. If there is not enough energy to make this happen, the atmosphere will shed. What is left of the star is an oxygen and carbon core. This is a remnant white dwarf. If a lot of energy is created when the atmosphere sheds, then the star will become a nebula. If the conditions are just right, the white dwarf could possibly explode into what we know as a 1A supernova. But this rarely happens. A star that is 1.5 through 4.9 times bigger than the Sun will become a neutron star. A neutron star is made out of a very dense mass of neutrons after it has collapsed under its own weight. If it is 5 times bigger than our Sun, when the hydrogen runs out, a supernova occurs. A supernova is extremely bright. In a spontaneous, violent explosion, it produces 10 to 100 million times the light that our Sun will produce in its lifetime. The star collapses on itself and then blows itself into smithereens. The leftover material condenses into a black hole.